To evaluate the limit at x goes to infinity, which is the end behavior of a rational function, or in some other cases, a ratio, instead of using the L'Hopital rule, we can use the precalculus method, which simply state that we simply take every single term and divide it by the highest power, but in the denominator only. The highest power in the denominator is x squared. And so we will take every single term and divide it by x squared. This is a rational function, so the numerator and the denominators are both polynomials, which are made up of terms. We then simplify each of these terms. 5x squared over x squared is 5. 2x over x squared is 2 over x. 5 over x squared stays 5 over x squared. X squared over x squared is 1. 3 over x squared stays 3 over x squared. And so we rewrite it at the limit at x goes to infinity of 5 minus 2 over x plus 5 over x squared over 1 plus 3 over x squared. And then we examine each of the terms. At x goes to infinity, meaning x is a very large number, 5 over x squared go to 0 because x squared is a very large number. 5 over a very large number is 0. Similarly, at x goes to infinity, 2 over infinity go to 0. 3 over x squared go to 0. And so we end up with 5 minus 0 plus 0 over 1 plus 0, which is 5. This might be quicker than using the L'Hopital rules. If we want to use the L'Hopital rules, we should end up with the same answer. We see that the numerator and the denominator are both continuous and differentiable, and x goes to infinity, the numerator goes to infinity and the denominator goes to infinity, and so we can use the L'Hopital rule. Using the L'Hopital rule, we take the limit at x goes to infinity and we differentiate the numerator and the denominator separately. The derivative of the numerator is 10x minus 2 plus 0, and the derivative of the denominator is 2x plus 0. We check that this is still infinity over infinity, so we can use the L'Hopital rule again. The limit at x goes to infinity, the derivative of 10x minus 2 is 10, and the derivative of 2x is 2. And so this is 10 over 2, or 5. We got the same answer. We do not need to show both methods. We do this to show that, regardless of which method we use, precalculus or calculus, the answer is the same.